Hello there, and welcome to the Sleepy Space Channel. Tonight, we are turning our gaze toward the soft band of light that has arched over every clear night of human history, the Milky Way, our home galaxy, seen always and only from the inside. 100 small, gentle facts about it are waiting for us. The shape of it, the slow turning of it, the quiet at its center, the unseen scaffolding that holds it together, the companions that drift in its halo. There is no urgency here. The galaxy has been doing what it does for almost the entire age of the universe, and it will keep doing it long after this video has ended. We are simply going to look up, gently, and notice. If you enjoy drifting off to space, I invite you to like, subscribe, or share a thought below. It helps others find their way here, too. One sleepy soul at a time. But for now, there is nothing you need to do but settle in. Let your shoulders soften. Let your breathing slow. Let the day fade away. Let's begin. The Milky Way is a galaxy. That word has a softer meaning than most people realize. A galaxy is simply a great, slow gathering of stars, gas, dust, and quiet matter, all held together by gravity, all turning around a common center, all drifting through a much larger dark together. Our home galaxy is one of these gatherings, and it has been turning gently for almost the entire age of the universe. It is shaped like a long, slow pinwheel of light. From far above, if anyone could ever look down on it, the Milky Way would appear as a soft, glowing disk, with curving arms unfurling from a slightly elongated center. Inside that disk, several 100 billion stars orbit in slow, patient circles. None of them is in a hurry. None of them is going anywhere new. They have been making their long laps for billions of years, and most will continue for billions more. You live inside this galaxy. So does every person you have ever known, and every person you will ever know. The Earth, the Sun, the Moon, the planets, every comet that has ever passed through our small neighborhood, all of them are members of this same gentle, turning structure. We are not visitors here. We have always been part of it. It can help to remember that even the word galaxy is a kind of soft inheritance. It comes to us through Greek, through Latin, through a long chain of small linguistic touches, all rooted in the simple word for milk. The galaxy was named for the appearance of the night sky long before anyone knew what they were looking at. The same gentle band of light that early shepherds saw, that desert travelers used to find their way, that countless people have looked up at and quietly puzzled over, is the same galaxy we are in tonight. The view does not really change. If you set out at the speed of light, the fastest possible way anything can move, it would still take you a full 100,000 years to cross from one edge of the disk to the other. The galaxy is not large in the way a building is large, or a country is large, or even a planet is large. It is large in a way that softens the meaning of the word. It is large enough that light, which crosses our solar system in only a few hours, takes 100 millennia to cross it. There is no rush in such a place. There cannot be. Anything that travels at human speeds is essentially still on the scale of the galaxy. Anything that travels at the speed of light still has more than enough room to wander. Distance, here, is patient. Distance, here, is one of the kindest qualities the universe has. And yet, despite its size, you can see it. On a dark, clear night, far from city lights, you can look up and find a soft, hazy band of light arching across the sky. That band is the Milky Way. You are looking edge-on through your own galaxy, through tens of thousands of light-years of stars, all stacked into a single quiet glow. The hazy quality of that band is not a flaw of vision. It is real. It is the result of millions of stars, too dim and too distant to resolve as separate points of light. They blur together into a soft glow, the way a great crowd at a great distance blurs into a single muffled hum. If your eyes were sharper, you would see the individual stars. As it is, you see them gathered, gently, into a single soft river of light. For almost as long as people have looked up at night, they have seen this band. Almost every culture on Earth has its own name for it. The English word, Milky Way, comes from an old word for milk, and the word galaxy comes from the same root. Other peoples have called it a river, a path, a road of stars, a backbone of night, a spilled basket of grain. The names are different. The soft band is the same. There is something tender about that. Across centuries and continents and languages we no longer speak, people have looked up at the same band of soft light and reached for the same kind of word. They saw what you see. They did not know how far away it was. They did not know how many stars made up the glow. They only knew that there was a soft river overhead at night, and they gave it a name, and the name was usually quiet. The galaxy you see when you look up is not just one of many galaxies. It is the only one we have ever lived inside. Astronomers now estimate that the visible universe contains perhaps 2 trillion galaxies. We have catalogued only a small fraction of them. They drift far away from us, separated by enormous, dark distances, and most of them we will never see clearly with our own eyes. But the Milky Way is right here. It surrounds us on every side. We are not looking at it from a distance. We are looking out from inside it. This is one of the gentle truths about our home galaxy. We will never see it whole. Every photograph that shows the Milky Way as a glowing pinwheel from above is either an illustration or a careful model. There is no spacecraft far enough away to take such a picture, and there will not be for any time we can reasonably imagine. We live inside the Milky Way. We see it from the inside. We feel its slow turning without feeling it at all. It is a strange and gentle thing to belong to a place you cannot fully see. We have built models of the galaxy out of careful measurements, the distances to stars, the motion of gas, the soft glow of dust. We can sketch its shape, paint its arms, place ourselves on its map, but we have never seen it from outside. We never will. The picture in your mind of the Milky Way as a beautiful pinwheel is a kind of imagining, gently true and gently provisional, like a child's drawing of a house from the inside, made by someone who has never stepped out the door. Tonight, we will simply walk through it. Slowly. 100 soft facts about our home galaxy, drifting one after another like small lanterns along a quiet path. There is no destination. There is no surprise at the end. There is only the galaxy, and the long quiet around it, and the soft light of it gently held above you. You can settle in now. The galaxy is not in a hurry. We have all the time in the world. There is something quieting about the simple act of looking up at a galaxy and knowing that the same view has been available, in roughly the same form, for the entire history of the human family. Long before there were telescopes, long before there were star charts, long before there were words for any of the constellations, people walking under the open sky saw the same soft band of light overhead. They did not know what it was. They did not know how far away it was. They did not know how many stars made it up. But they saw it, and so do you, and the galaxy has not noticed any of the long evolution between their sight of it and yours. If you imagine all the people across all of human history who have ever looked up at the Milky Way at night, the number begins to soften under its own size. Hunters watching the sky for the next day's weather. Travelers using the band as a rough north-south line. Children who simply liked the way the stars were arranged. Lovers walking home in the dark. Sleepless people on long, slow nights. Each of them looking up at the same gentle band, the same calm spiral seen from the inside, the same slow turning that you are inside now. The galaxy has carried all of that, gently, without keeping a record. It does not need to. The galaxy was never the audience. The galaxy is only the place. It is enough, for the moment, to know that you are inside something old, soft, vast, and patient, and that you do not have to do anything about it. You can let your shoulders settle. You can let the day slip a little further behind you. You can let the long, quiet turning of the galaxy carry you for a while, the way it has been carrying everyone who has ever lived, including, for a brief shimmer of time, the people in your own life. The Milky Way is, more than anything else, the place where everything you have ever known has happened. Every sunrise you have ever seen happened inside it. Every face you have ever recognized exists inside it. Every breath you take tonight is happening inside it. The galaxy is not somewhere else. It is right here, soft, slow, and around you in every direction. The Milky Way is a barred spiral galaxy. That is its formal description, and it is a useful one to begin with. Spiral, because it has long, curving arms made of stars, gas, and dust. Barred, because at the very center of the disk runs a long, slow bar of older, redder stars. The bar is gently elongated, like a softly rounded almond, and the spiral arms unfurl from the ends of it. This shape is not unusual in the universe. Many of the largest galaxies are spirals. Many of those spirals have a central bar. The Milky Way is, in many ways, an ordinary galaxy. It is not the largest. It is not the smallest. It is not the brightest. It is not the oldest. It is simply one of perhaps 2 trillion galaxies in the observable universe, doing what galaxies do, on a timetable so slow that human lifetimes barely register against it. There is a quiet comfort in being ordinary. A galaxy that is one of trillions does not bear the weight of being special. It does not need to justify itself. It simply continues, like a tree among trees, like a wave among waves. The Milky Way is unremarkable in number, but it is the only one we have ever lived inside, and that is enough to make it the most important galaxy in our local sky, while still letting it be unremarkable in the wider universe. The disk of the galaxy is wide, but very thin. If you imagine a spinning plate, you are close to the right idea. The plate is roughly 100,000 light-years across. The plate is only about 1,000 light-years thick at its center, and even thinner where the youngest stars and the most recent star-forming gas live. The Milky Way is a flat structure. The arms, the dust, the gas, the new stars, almost all of them lie in this thin, broad sheet. Above and below the disk, the galaxy is wrapped in a softer, more diffuse glow. This is the halo. The halo holds older stars, ancient star clusters, and a vast amount of mass that we cannot see directly. The halo extends much, much farther than the visible disk. From the outside, the disk would shine brightly, and the halo would fade gently into the dark around it. The halo is, in many ways, the quiet, older sibling of the disk. While the disk is busy turning and producing new stars, the halo is simply there, gently filled with the oldest stars in the galaxy, with ancient clusters that orbit on long, slow paths, with diffuse gas drifting in and out, and with the much greater unseen mass that holds everything together. The disk is where the visible action of the galaxy is. The halo is where its memory lives. At the very center of the galaxy is the bulge. The bulge is a thicker, peanut-shaped region of older stars packed together more densely than anywhere else in the galaxy. From a great distance, the bulge would look like a small, golden core in the middle of the wider disk. Inside the bulge sits the bar. Inside the bar sits the very center, which we will visit later. For now, it is enough to know that the heart of the galaxy is dense, slow, and warm with old starlight. The spiral arms unfold outward from the ends of the bar. The Milky Way has 4 major arms, with several smaller spurs threaded between them. The major arms are called the Perseus arm, the Scutum Centaurus arm, the Sagittarius arm, and the Norma arm. These names come from the constellations they appear to lie within when seen from Earth. They are not solid structures. They are not made of any one set of stars. They are slow patterns, regions where stars and gas pile up briefly as they orbit through, brightening as they pass. It is worth letting that idea settle for a moment. The arms are not made of fixed stars. They are made of crowding. Stars drift in and out of an arm over millions of years, much the way drivers drift in and out of a slow stretch of highway. The arm appears bright, not because the same stars stay there, but because at any given moment, more stars happen to be passing through that region than passing through the regions just before or after it. The shape we recognize as a spiral is, in a soft sense, only a momentary photograph of a much longer flow. You live in a small branch between 2 of these arms. It is called the Orion spur. The Orion spur sits between the Sagittarius arm and the Perseus arm, like a quiet path between 2 larger streets. The Sun and its planets drift along the Orion spur, slowly carried by the larger turning of the disk. There is nothing especially remarkable about our location. We are not at the heart of anything. We are not at the edge of anything. We are roughly halfway out from the center, in a calm corner of a much larger structure. That distance is about 26,000 light-years. From the heart of the galaxy to where you are right now, the light has been traveling for 26,000 years. And from where you are right now to the outer edge of the visible disk, light would take roughly another 25,000 years more. The Sun lives in the suburbs of the Milky Way, on a small spur in a quiet stretch of disk, doing exactly what every other star nearby is doing. Turning, slowly, in the long dark. The suburbs of the galaxy are gentle. The local density of stars is moderate. The local supply of gas and dust is moderate. The local rate of supernovae and nearby cosmic events is moderate. We are not in the busy heart, where stars crowd and old supernova remnants jostle one another. We are not in the lonely outer reaches, where stars are spread thinly and visit one another only across great distances. We are in the calm middle band of the disk, where life has had plenty of room and plenty of time to unfold quietly. Far from the center, the disk gently warps. On one side, it bends slightly upward. On the other side, it dips slightly downward. This warp is not a defect. It is a gentle, slow flexing of the outer galaxy, possibly caused by long-ago interactions with smaller companion galaxies. The Milky Way is not perfectly flat. It is not perfectly symmetric. It leans, very softly, the way a sleeping body leans. There is comfort in remembering that we live inside this shape. Every direction you can look at night is into the galaxy. Up, down, sideways, backward, forward, all of it is the Milky Way. The night sky is not a window onto something distant. It is a view from inside something enormous. And no matter how often the world feels small or fragile, the place we live is held inside a galaxy 100,000 light-years across, turning slowly through the dark, carrying us along without asking. The night sky you have known your whole life is, in this sense, a kind of inner wall. The brightest stars, the gentle band of light, the constellations and the dark spaces between them. All of it is the Milky Way arranged around you. The same is true for someone on the other side of the planet, looking up at their own night sky. We are all looking outward from the same gentle interior. We are all standing in the same slowly turning room. The shape of the Milky Way is not just a static drawing. It is a structure that is constantly, very slowly, in motion. The disk is rotating. The bar is rotating, but at a slightly different rate. The spiral arms are slow patterns within the rotating disk. The bulge is turning at its own pace. The halo is mostly still, but its own internal orbits are nothing if not patient. The whole structure looks calm because everything inside it is moving at scales we cannot directly perceive. The bar at the heart of the galaxy is itself a soft, surprising shape. It looks, in careful surveys, slightly tilted relative to a line drawn from the Sun to the galactic center. It runs through the center of the galaxy at a gentle angle, several thousand light-years long, made up mostly of older, redder stars. Inside the bar, the orbits are not circular. The stars there move on more elongated paths, gently brushing along the length of the bar before swinging back. The bar is, in some sense, a slowly turning rod of older stars set inside the broader spinning disk. The spiral arms unfurl from the ends of the bar in long, soft curves. From a position above the disk, the spiral pattern would look almost decorative, the kind of swirl an artist might paint. From inside the disk, you cannot see the swirl directly. You can only see it indirectly, by mapping the locations of young, bright stars, and of glowing nebulae, and of dense clouds of gas. When astronomers piece those maps together, the spiral pattern emerges, gently traced by the brighter stars and the gas they were born inside. The disk has another quiet feature that is worth knowing. It is denser nearer the center, and thinner farther out. Near the bulge, stars are packed more closely together. In the suburbs, where the Sun lives, the average distance between stars is several light-years. In the outer disk, that distance grows even larger. The galaxy is dense at the heart and gentle at the edges, like many living things. It is also worth holding the idea that we live inside a structure with a top and a bottom, even though those words are not really accurate. The disk has a plane. The Sun sits, on average, a small distance above or below that plane, depending on where in its slow vertical bobbing cycle it currently is. The plane of the galaxy is therefore visible, from Earth, as a faint imaginary line through the band of the Milky Way, with stars slightly more concentrated along it than off to either side. When you walk outside on a clear, dark night and look up, you are seeing all of this geometry at once, blurred together into a single soft impression. You cannot pick out the bar. You cannot trace the spiral arms by eye. You cannot see the bulge as a separate structure from everything else. You can only see the long band of light, gently arching, with brighter knots and darker patches, and the rest is the careful work of generations of astronomers who have slowly mapped what your eyes alone cannot resolve. The shape of the galaxy is the shape of your home. You will never visit the bar at the center. You will never walk the outer edge of the disk. But the shape itself is yours in a small and quiet way. You belong to the disk, in the suburbs of the spiral, on a small spur, around a calm middle-aged star. That shape has been holding you longer than you have known. The Milky Way moves, but it never seems to. From the inside, you cannot feel the turning. You cannot see it from one night to the next. The patterns of stars overhead look the same to you as they did a year ago, and to the people who looked up at them 100 years before that. The galaxy turns far too slowly for any human eye to notice. And yet it is turning, all the time, without rest. At our distance from the center, the galaxy moves at about 220 kilometers per second. That number sounds large in human terms. It is large enough that if you could feel it, your stomach would drop. But on the scale of a galaxy, it is barely a drift. It would take the sun more than 200 million years to make one full lap around the heart of the Milky Way at that speed. One full lap is called a galactic year. A galactic year is not a useful unit for daily life. It is not even a useful unit for the longest human projects. But it is a kind unit for thinking about the Sunday. Most things we measure in years pass by quickly. A galactic year barely moves. The sun's life, measured in galactic years, becomes a comfortably small number, just a handful of laps so far, with many more still to come. In all the time the sun has existed, in the 4.5 billion years since it formed from a quiet collapse of gas and dust, it has only completed about 20 galactic years. 20 laps. That is the entire history of the sun, the planets, and the long story of life on Earth, all packed into about 20 slow circuits around the galactic center. The dinosaurs walked the Earth for the better part of one galactic year. Modern humans have existed for less than 1/10 of a single one. Every empire, every language, every memory you have ever inherited has happened in a fraction of one slow lap. The galaxy is calm, in part, because it is so much older and slower than anything inside it. You can sit with that comparison for a moment. Every story you have ever read, every life you have ever heard about, every great event in human history, all of it has happened in a small slice of a single turn of the Milky Way. The galaxy could blink and miss us if galaxies blinked. The galaxy does not blink. It simply turns. We turn with it. Closer to the center, stars move on shorter timetables. The bar at the heart turns as a single, slow structure. The stars that orbit very close to the central black hole make a full loop in only a few thousand years, or in some rare cases, only a few decades. Farther out, in the halo and the most distant edges of the disk, stars on long, lonely orbits can take billions of years to circle the galaxy once. A strange thing happens when astronomers look at how stars move at different distances from the center. Closer in, the orbits behave roughly the way you would expect from gravity alone. The closer you are, the faster you go. But farther out, the rotation does not slow down the way the visible mass would predict. Stars at very different distances from the center all move at nearly the same speed, in a flat, gentle pattern. Something invisible is keeping them in step. That invisible something is dark matter, and we will return to it gently later. For now, it is enough to know that the Milky Way is held together not only by the stars you can see, but by a vast, quiet halo of mass that we cannot see at all. The galaxy is more than its starlight. It is also the slow, unseen scaffolding that lets the starlight turn together. The spiral arms of the Milky Way are not solid. The arms do not stay attached to particular stars. Instead, the arms are slow-moving patterns, like ridges of sand in a slowly moving stream. As stars and gas drift through an arm on their longer galactic orbit, they pile up briefly, like cars passing through a slow zone of traffic. New stars form in these gentle traffic jams, lighting up the arms more brightly than the regions between them. Then, after a while, those same stars drift on through to the calmer parts of the disk. The Sun has passed through the arms many times. It will pass through them many more. Each crossing is so slow that it makes no difference to anything you would notice in your life, or in the life of your great-grandchildren, or in the life of the entire human species so far. But on the long timetable of the galaxy, those passes are part of the steady rhythm. The galaxy breathes in long, soft turns, and we drift along with it. There is a particular comfort in knowing that the Sun has been doing this for a very long time. Long before the Earth had oceans, the Sun was passing through spiral arms. Long before the Earth had a single living cell, the Sun was making slow laps of the disk. The Sun has been part of the same long pattern for as long as it has existed. By the time it next swings through one of the major spiral arms, you will be long asleep, and so will many generations after you. On top of this great orbit, the Sun is also doing other, smaller things. It is bobbing slowly up and down through the plane of the disk on a much longer cycle, gently rising and falling like a buoy in a calm sea. It is drifting through a small, soft cloud of interstellar gas called the local interstellar cloud, which is a kind of weather pattern at galactic scale. And the entire Milky Way itself is moving, falling toward Andromeda, drifting with the local group, riding much larger flows of galaxies through the universe. You never feel any of it. Not the orbit, not the bobbing, not the drift, not the larger flow. The motion is too smooth, too steady, too gentle. The galaxy simply carries you, the way a slow river carries a leaf, the way the night carries a sleeping body, the way all very large, very patient things carry the small, quiet things inside them. The lack of any sensation of this motion is not a mistake of your senses. It is a result of how perfectly the motion is shared. Every cell in your body, every molecule of air around you, every grain of dust in the room is drifting along at the same speed, in the same direction, on the same gentle path. There is no relative wind to feel, no shake, no jolt. You are not standing still. You have just been moving so steadily for so long that the motion has become the background of every moment. It is sometimes humbling to think about how little of the galaxy's motion we have ever actually measured directly. The full orbit of the Sun around the galactic center has never been observed, because no one has lived long enough to see it. The galactic year is a calculation, not a memory. We measure the Sun's velocity, we measure the gravity at our distance from the center, and we infer the orbit from those measurements. We have never watched the Sun complete a single lap. No one ever will. The same is true for almost every other long galactic motion. The drifting of stars through the spiral arms, the bobbing of the Sun above and below the disk plane, the slow vertical breathing of the galactic atmosphere, all of it is calculated rather than directly seen. The galaxy moves on timescales that are much longer than every careful instrument we have ever built. The motions are real, but they are also, in a real sense, beyond our ability to witness. We know them by inference, by patience, and by the slow accumulation of careful observations. There is a kind of soft trust involved in working with such things. Astronomers have to trust that the galaxy continues to move the way it appears to be moving, even though no one will be around to confirm a full galactic year. The motion is real. The orbit is real. But the experience of watching it complete itself is not available to any human life. The Sun has only completed about 20 galactic years since it formed. By human standards, 20 laps is only a few minutes worth of running. By galactic standards, it is the entire history of our planet. It can be a relief to belong to something whose pace is far beyond your own. You will never have to hurry to keep up with the galaxy. The galaxy will never ask you to. It moves at its own rate. It does not care whether you have noticed. It has been turning before any of your ancestors were noticed by anyone, and it will continue turning long after any record of you has dissolved into time. The slow turning of the galaxy will not stop tonight. It has not stopped on any night anyone has ever known. It will not stop while you sleep. It will simply keep doing what it does, gently, around you and through you, while you settle into your own much smaller rhythms. Your breathing is small. The galaxy is large. Both of them are turning at their own steady pace. The Milky Way is full of stars, but not the kind of stars most people picture when they hear that word. The bright, sun-like stars that appear in our sky are not the most common kind in the galaxy. They are not even close to the most common. The galaxy is dominated, in sheer numbers, by small, quiet, red stars called red dwarfs. A red dwarf is a star that is smaller and cooler than the Sunday. It glows softly, often with a deep orange or red light, and it burns its fuel so slowly that it can shine for trillions of years. Most of the stars in the Milky Way are red dwarfs. Most of the stars in any galaxy, in fact, are red dwarfs. They are the long-lived, patient majority, doing their gentle work in quiet corners of every disk and halo in the universe. There is something kind about that. The most common kind of star in the universe is also the most patient. The galaxy is filled with stars that will outlast almost anything you can name. They will keep shining when sun-like stars are gone, when blue giants have long since exploded and faded, when the universe has aged far beyond anything we can really picture. The galaxy is built, in some quiet way, to keep glowing for a very long time. The reason you do not see them well from Earth is simply that they are dim. The night sky is not a fair sample of the galaxy. The brightest stars overhead are almost always the largest, hottest, rarest stars, blue giants, white-blue main sequence stars, swollen red giants in their later years. These massive stars are uncommon, but they shine so brightly that they color the appearance of the galaxy out of proportion to their actual numbers. The Sun sits in between. It is brighter than most stars in the galaxy and dimmer than the rare giants. It is a quiet, middle-aged star, neither remarkable nor especially humble, with a planet that has somehow grown the kind of life that looks up at the sky and asks where it came from. It is worth noting how unusual it is, in galactic terms, to live around a star like the Sunday. Most planets in the galaxy probably orbit red dwarfs, simply because there are so many more of them. Around a red dwarf, the habitable zone is much closer to the star. The light is redder. The years are shorter. The conditions are different in many small ways. The Sun, by being a sun-like star, has given us a particular kind of sky, and a particular kind of year, and a particular kind of warmth, that is, in galactic terms, a quieter version of common. Stars in the Milky Way are sorted, in a soft astronomical shorthand, into populations. Population I stars are the younger ones, including the Sunday. They live mostly in the disk. They move on nearly circular orbits along the galactic plane, They contain a richer mixture of heavier elements because they formed from gas that earlier generations of stars had already enriched. Population 2 stars are the older ones. They live mostly in the halo and the bulge. They travel on long, plunging orbits that dive in and out of the disk on slow, looping paths. They contain a simpler chemistry because they formed when the universe itself was younger and had not yet gathered as much heavy material. There is also a third, hypothetical population called Population 3. These are the very first stars, made of almost pure hydrogen and helium, born when the universe was barely more than a few 100 million years old. None of them have ever been directly observed. They may have all lived and died long ago, leaving behind the heavier elements that every later generation of stars now contains. The very first lights of the universe are quietly remembered in everything that came after. It is a soft thought. The galaxy carries the memory of stars that came before our records began. Every iron atom in the bar, every oxygen atom in your lungs, every carbon atom in the grass outside, all of it was made inside earlier stars, including, in some small fraction, those very first stars whose names and whose individual lives no one will ever know. The galaxy is older than its records. The atoms remember more than we do. Some of the stars in the halo are nearly as old as the universe itself. They are more than 13 billion years old, drifting through the galaxy on slow orbits older than the Sun, the Earth, and almost everything you can name. They were already old when the disk was still settling. They were already old when the first molecular clouds in the bar collapsed into the first generations of disk stars. They have been turning quietly in the halo for almost the entire history of time, and they will keep turning long after we are gone. Despite its age, the galaxy is not a fossil. The Milky Way is still making stars. Roughly 1 to 3 new stars form every year, on average, from cold molecular clouds in the spiral arms. A baby star is rare, by galactic standards, but it is not rare in the way an event is rare. It is part of a slow, steady creativity. The galaxy quietly produces new suns at about the same rate it has been producing them for a long, long time. If you take a moment to imagine the galaxy as a slow, living thing, this is one of its quieter rhythms. Every year, give or take, the Milky Way breathes out 1 or 2 new stars. Every year, somewhere in the disk, gas that has been waiting in a cold cloud for millions of years gathers itself together, falls inward, ignites, and joins the long population of stars. The galaxy is, in this small way, ongoing. It is not finished. It is still in the middle of itself. Most new stars are born in stellar nurseries, vast cold clouds of gas and dust that have, by some quiet trigger, started to collapse under their own weight. As the gas falls inward, it heats and condenses into a dense core, and at last begins to shine. One of the closest visible nurseries is the Orion Nebula, where new stars are forming inside a softly glowing cloud only a few hundred light-years from Earth. When you look up at Orion in the winter sky, you are looking, in a small way, at the galaxy still creating itself. Stars in the Milky Way often come in pairs, in triples, in larger groupings. More than half of all stars are not alone. They orbit a companion across slow, soft cycles, sometimes once every few days, sometimes once every million years. The Sun is, in this respect, mildly unusual. It is by itself. But many of the stars you see in the night sky are members of small families, holding their orbits together for as long as their lives last. Throughout the disk, hundreds of open clusters drift loose, gentle groups of newly born stars that all formed from the same molecular cloud, and now share the same general orbit. Over millions of years, these open clusters slowly disperse, their member stars drifting apart into the wider disk. Far above and below the disk, in the halo, drift the globular clusters, much older, much tighter, bundles of hundreds of thousands of stars. There are roughly 150 globular clusters orbiting the Milky Way, each of them an ancient, dense city of stars on a long, looping orbit. A globular cluster, seen from inside, would have a sky unlike anything we know. Stars would crowd together so closely that the night would never really be dark. Bright stars would shine in many directions at once, like distant city lights through a soft mist. A planet inside a globular cluster, if any survived there, would have a sky utterly different from ours, and a sense of the universe that we will probably never share. And almost every star, of any size or age, has at least one planet. The Milky Way is not just a galaxy of stars. It is a galaxy of worlds. We do not yet know what most of those worlds look like. We do not yet know how many of them carry oceans, or atmospheres, or weather, or life. But the wider truth is gentle and worth holding for a moment. Almost every point of light overhead is also a system. Almost every star is also a place. Stars in the Milky Way are sorted by age, but they are also sorted by chemistry. The Sun is what astronomers gently call a metal-rich star, meaning, simply, that it contains a slightly higher fraction of elements, heavier than hydrogen and helium, than the older stars in the halo do. Those heavier elements are not metal in the everyday sense. To an astronomer, almost everything that is not hydrogen or helium is called a metal. Carbon is a metal. Oxygen is a metal. Iron is a metal. Calcium is a metal. The sun, the earth, your body, all of us are made of what astronomers call metals, which is to say, of everything that came after the first generations of stars made it. Older stars, especially those in the halo and in some of the inner bulge regions, contain a smaller fraction of these heavier elements. They formed earlier in the history of the galaxy, before many earlier stars had lived and died. Their chemistry is simpler. Their planets, if they have any, are likely to be simpler too. The galaxy is, in a real sense, slowly enriching itself over time. Each generation of stars hands its leftovers to the next, and the next generation is a little richer in heavy elements than the one before. This is why the Sun was able to form a planet like the Earth. The Sun is a relatively recent star, formed long after many older stars had already done the slow work of producing the heavier elements that the Earth needed. There is iron in the Earth's core because earlier stars produced it. There is silicon in the Earth's crust because earlier stars produced it. Even gold and silver, the heavier elements that show up in fine traces, were forged in the catastrophes of older stars and gently scattered into the gas from which the Sun and its planets eventually formed. The galaxy is, in this sense, a slow gift between generations. The earliest stars left their heavier elements behind for the next generation. That generation produced their own heavier elements and left those behind too. Over and over, across billions of years, the chemistry of the disk became richer. By the time the Sun formed, the gas around it was richer than it had ever been before. By the time the Sun's children, if it has any, in some metaphorical sense, will form, the disk will be richer still. It is calming to remember that you are made of those gifts. Every atom of iron in your blood was once part of an earlier star. Every atom of carbon in your hands was once part of an earlier star. The galaxy is not a finished thing, but it has been, in its slow way, generous to the small lives it has gathered. You are part of that generosity. So is the chair you are sitting in, and the air you are breathing, and the light from any nearby lamp that has fallen across this room. The light overhead, when you can see it, comes from many different kinds of stars across many different ages. Some of the light reaching your eye tonight comes from stars that are no longer there, stars whose actual lives ended thousands or millions of years ago, but whose light is still on its way. The galaxy is full of these slow goodbyes. The light continues even after the source is gone. It is, in its own quiet way, a kind of patience. At the very center of the Milky Way sits a supermassive black hole. The phrase sounds dramatic. It does not need to be. A black hole is, in its own way, one of the calmest objects in the universe. It is a region of space where gravity is so strong that not even light can escape, and once material has fallen across its boundary, called the event horizon, it does not return. From the outside, a black hole looks like a quiet absence, a small place where the galaxy has folded inward. It is a useful, gentle picture to hold. The center of the galaxy is a place where motion stops. Everywhere else in the Milky Way, things are moving. Stars are orbiting, gas is drifting, light is traveling. But at the very heart, surrounded by all that motion, sits a region from which no motion ever returns. It is a kind of stillness, held inside the spinning of everything else. The central black hole of the Milky Way holds the mass of about 4 million suns. That is enormous on the scale of a single star. It is also small on the scale of a galaxy. Compared with the total mass of the Milky Way, the central black hole is only a tiny fraction. The galaxy is not held together by the black hole. It is held together mostly by the gentle gravity of all its stars, gas, and dark matter spread across the disk and halo. The black hole is just the most concentrated point in the very center. The black hole has a name. It is called Sagittarius A star. The name comes from the constellation Sagittarius, which is the direction in the sky where the heart of the galaxy lies. If you look toward the constellation Sagittarius on a dark summer night, you are looking, more or less, toward the center of the Milky Way. The light from there has been traveling for about 26,000 years to reach you. The galaxy at the heart, when you see it, is a memory. 26,000 years ago, no one had built any of the cities that now exist on Earth. Most of the languages spoken today had not yet diverged from their ancient roots. The light, leaving the heart of the galaxy, then has only just arrived now, after crossing 26,000 light-years of the disk. When it finally reaches your eye on a clear night, it is older than nearly everything you have ever heard of. It carries, in a soft way, a portrait of the galactic center as it was, not as it is. For most of its time, Sagittarius A star is quiet. It is not actively feeding. It is not blazing with light. There are galaxies elsewhere in the universe whose central black holes are much more active, drawing in vast amounts of gas and shining as some of the brightest objects in the sky. The Milky Way is not one of those. Our central black hole is in a low, restful state. It draws in only small amounts of gas and dust, and most of the time it produces no light we can see at all. A few years ago, an extraordinary thing happened. Astronomers around the world used a network of radio telescopes spread across the planet to gather faint light from very near the heart of the galaxy. By combining the light from all of those telescopes at once, they were able to see, for the first time, the soft glow of gas spinning around our central black hole. The result was a small, gentle ring of light surrounding a darker center. It was the first direct image of the shadow of Sagittarius A star. It looked, in many ways, like an afterthought of a photograph, a dim ring of warmth around a quiet darkness. The image is not a portrait in the usual sense. It is more like a fingerprint. It does not show the black hole itself, because the black hole emits no light. It shows the soft glow of matter just outside the event horizon, bent and shaped by gravity into a ring around the place where light cannot escape. It is what we are allowed to see. It is the boundary, gently lit. The center itself remains, and probably always will remain, just out of sight. Around the central black hole orbits a small group of stars called the stars. They live in an extremely tight, busy region around the black hole, where space curves more sharply than anywhere else in the galaxy. These stars whip around the central black hole at extraordinary speeds, on highly elongated orbits that bring them very close to it before swinging them back out again. One of these stars, called S2, completes its orbit in only about 16 years. To live near the heart of the galaxy is to be on a much faster timetable than the rest of us. To live in the suburbs, as the Sun does, is to make one orbit every 250 million years. Surrounding the central black hole and the stars is a dense cluster of millions of stars. This is the nuclear star cluster. It is the most crowded neighborhood in the galaxy, where stars sit close enough together that their distances are sometimes only a fraction of a light year. It is still mostly empty space, by everyday standards. But by galactic standards, it is dense enough that the night skies of any planets there, if any survive, would be unlike anything we have ever seen. A sky in the nuclear star cluster would never go fully dark. There would always be many bright stars overhead at once, and the diffuse glow of millions of others mixed in between. A nightingale could not really sing about a starry night there in the way a poet on Earth could. The night would never be that quiet. The light would always be coming from too many directions at once. It is one of those places in the galaxy where the very meaning of nighttime would be different. Some of the stars in the inner bulge formed before the disk of the galaxy had fully settled. The very heart of the galaxy is, in places, older than the wider spiral around it. The center of the Milky Way is not just a black hole. It is a gathering of ancient stars that have been orbiting close to the gravitational center for almost the entire age of the universe. Stretching above and below the galactic plane are two enormous, faint structures called the Fermi bubbles. Each one extends tens of thousands of light-years above and below the disk. They are not visible to ordinary eyes. They glow faintly in high-energy light, gentle ghosts of past activity. They suggest that, millions of years ago, the central black hole was much more active than it is now. Something happened, a burst of feeding, a sudden inflow, a quiet tantrum on the time scale of a galaxy, and the Milky Way blew two enormous, soft bubbles out of its plane. Those bubbles are still there now, still slowly fading, still a record of an event that happened long before any of us could have witnessed it. The bubbles do not feel like anything from the inside. They are too diffuse, too vast, too quiet. We pass through their lower edges without noticing. Our planet, our solar system, our local arm, none of us have any awareness of the great soft balloons rising and falling above and below us. They are simply part of the larger landscape of the galaxy, a quiet record of a louder time. From Earth, the heart of the Milky Way is veiled. Thick clouds of dust along the galactic plane block almost all of the visible light from the center. We cannot easily see Sagittarius A star with our eyes or with optical telescopes. We can see it in radio waves, in infrared light, in X-rays, in visible kinds of light that can pass through the haze. The galactic center is hidden the way a quiet room can be hidden behind closed curtains. The light that reaches us from there is strange, careful, and mostly unseen by ordinary eyes. Today, the heart of the Milky Way is calm. It draws on slow tides of gas. It holds its stars close. It produces brief, soft flares now and then, faint flickers that rise and fade within hours. It does not seem to be moving toward anything dramatic. It simply turns at the very still center, around which everything we know is gently revolving. The center of the galaxy is, in many ways, the place where the most extreme things in the Milky Way are gathered. It is also, in many ways, the place where almost nothing dramatic seems to happen on any given night. Both things are true at once. There is enormous mass at the very center. There are stars on extreme orbits. There is a black hole. There are clouds of dust. There are flares. And yet, on the timescale of any one human life, almost nothing visible takes place. The center simply continues, in its strange, dense quiet. The supermassive black hole at the heart of the galaxy is not eating much. It is not bright. It is not active in the way some other galactic cores are. It draws in only small amounts of material, and only occasionally. Most of the time, the gas and dust near the center simply orbits quietly, never quite falling all the way in. The galaxy has been like this for a long time. The Fermi bubbles tell us it was not always so. But for now, the central engine of the Milky Way is at low idle. It is breathing softly, not roaring. If you could fly inward toward the galactic center, the things you would notice first would not be the black hole itself. They would be the increasing density of stars, the increasing brightness of the surrounding sky, the way the stars seem to crowd together as you go in. Far enough in, the night sky around you would never really get dark. The light of millions of nearby stars would saturate every direction at once. You would no longer see individual constellations. You would see a great soft glow, with bright stars scattered through it, and behind everything, deeper still, a small region from which no light returns. The stars at the very center of all of this are running the fastest galactic laps we know about. Some of them complete a full orbit around the central black hole in only decades. Their orbits are extremely elongated, like comets pulled around the sun, but on much sharper paths. From a careful telescope, the patterns of their motion can be seen unfolding over years. The motion of those small, bright stars is the closest, most reliable way we have to measure the mass of the central black hole. They are gentle pointers, doing their slow work of letting us see something we cannot see directly. The central black hole, in turn, is one of the calmer members of its kind. Other galaxies host central black holes that are millions, even billions, of times more massive than ours. There are quasars elsewhere in the universe whose central engines outshine entire galaxies, including their own. The Milky Way's central black hole is not in that league. It is moderate in mass, modest in activity, and very quietly tucked into the heart of an otherwise ordinary spiral galaxy. We are, in this respect, lucky to live around such a calm version of an extreme thing. The very heart of the galaxy is also a place of strange time. Near a supermassive black hole, gravity warps the passage of time itself, in soft, almost imperceptible ways. A clock placed near the central black hole would tick slightly more slowly than a clock placed out in the suburbs of the disk where the sun lives. The difference is small at our distance, but real. It is one of the gentlest reminders that the galaxy is not a stage set with a fixed clock running through every part of it. The galaxy holds many small, slow versions of time at once, all gently woven together by the pull of mass. The stars at the center, on their fast, tight orbits, experience time slightly differently than the stars in the wider disk. The differences are tiny, by any practical measure, but they are real. The galaxy is, in a quiet way, a place where the very rhythm of time is woven into the rhythm of gravity. It is not a steady metronome. It is a soft, varying heartbeat, slower nearer the heart, faster farther out, all gently in sync without ever being identical. The center of the galaxy will continue to be quiet tonight. The black hole there will not flare. The stars will continue their fast, small orbits. The nuclear cluster will keep its dense, steady glow. None of it requires your attention. The center of your home galaxy is doing fine without you, and it has been doing fine without anyone for almost the entire history of time. Between the stars of the Milky Way, the galaxy is not empty. It is filled with a thin, cold mist of gas and dust called the interstellar medium. This material is incredibly diffuse, far thinner than any laboratory vacuum on Earth. But across a galaxy 100,000 light-years wide, even something thin can add up to a great deal. About 3/4 of this gas is hydrogen, the simplest element in the universe. The rest is mostly helium, with only a small fraction of everything else: carbon, oxygen, nitrogen, iron, and the heavier elements that came from earlier generations of stars. The galaxy is, in a quiet way, a vast hydrogen sea, with islands of more complicated matter scattered across it. It is gentle to think of it that way. The galaxy is, in chemical terms, simple. Most of it is the lightest, oldest element. The complicated matter, the carbon, the oxygen, the iron, the calcium, exists only in small fractions. Yet from those small fractions, planets are made, and oceans, and air, and bodies. The complexity of life is built out of a small minority of the galaxy's atoms, drifting in a vast, simple sea. The densest gas does not stay spread evenly. It gathers, slowly, into vast cold clouds called molecular clouds. These clouds are dim, dusty, and so cold that simple molecules like hydrogen and carbon monoxide can survive inside them. A single molecular cloud can stretch dozens or even hundreds of light years across. Inside, gravity does its slow work, drawing material together into clumps, and inside the clumps, new stars are quietly born. The largest reservoirs of material in the disk are not stars or planets. They are the cold, dim places where new stars are not yet stars. Mixed into the gas are tiny grains of dust, smaller than smoke. These grains are made of silicates and carbon and other simple materials, and they scatter starlight in soft, painted ways. Nebulae get their colors from these grains. Bright regions become tinted with reds and blues. Dark regions become silhouettes, blocking the stars behind them. The visible texture of the spiral arms, their painted, layered look, comes mostly from the way light passes through and around this dust. If you have ever seen a photograph of a glowing nebula with curtains of pink and blue gas threaded with darker dust lanes, you have seen the interstellar medium made visible. The gas glows because it is being lit by nearby stars. The dust appears as silhouette where it blocks the light from behind. The whole image is a slow, soft portrait of the medium between the stars, briefly revealed by the stars themselves. Through the disk also run vast cavities of hot, thin gas. These cavities are bubbles, blown open by the force of past supernovae. When a massive star reaches the end of its life and explodes, it blasts the surrounding gas outward at enormous speeds, carving a low-density region into the interstellar medium. Over time, those bubbles expand, merge, and gently reshape the structure of the disk. The galaxy quietly sculpts itself with every dying star. The Sun lives inside one of these bubbles. It is called the local bubble, and it is thought to have been carved out by ancient supernovae, perhaps tens of millions of years ago. The Sun has been drifting through the local bubble for a long time, surrounded by a region of relatively low-density gas. We cannot see the local bubble with our eyes, but it is the gentle envelope in which our entire solar history has, for a long time, taken place. Our entire experience of the night sky has been from inside this bubble. The constellations as we know them, the seasonal patterns of stars, the soft band of the Milky Way, even the way the Sun's solar wind interacts with the surrounding interstellar gas, all of it has been shaped, in small ways, by the fact that we live inside a low-density cavity carved out by ancient explosions. It is a soft inheritance from a violent past. The whole galaxy is also threaded with a faint magnetic field. This galactic magnetic field is far weaker than the Earth's, only a millionth as strong, in fact. But it stretches across the entire disk, gently guiding the flow of gas and the paths of high-energy particles. Cosmic rays particles flung outward by supernovae and other violent events drift across the galaxy along the field's curving lines, gently pressing on the gas as they travel. And then, around all of this, holding everything in place, there is the dark matter halo. Most of the mass of the Milky Way is not in its stars, or its gas, or its dust. Most of its mass is in something we cannot see. It is called dark matter because it does not give off light, does not absorb light, and does not interact with ordinary matter the way we are used to. We know it is there because of how the galaxy moves. It is the dark matter that keeps stars in the outer disk turning at the same speed as those farther in. It is the dark matter that keeps the galaxy from flying apart. There is something strangely calming about this. The thing that holds your home galaxy together is something we cannot see. We have known about it for less than a single human lifetime. We do not know what particles compose it. We do not know how it interacts with itself, except very gently. And yet without it, the Milky Way would not be the galaxy it is. The shape of our home, the steady rotation of the disk, the long patience of the spiral arms, all of it depends on a vast, quiet presence we have never directly touched. The dark matter halo is much larger than the visible disk. It extends roughly at least 300,000 light-years in every direction from the galactic center. The visible Milky Way sits inside this halo like a bright, painted fish inside a much larger, invisible bowl. We do not yet know what dark matter is made of. We only know that it is there, that it is patient, and that it has been holding the galaxy together for a very long time. Above and below the visible disk drifts a thin, hot atmosphere of gas, a galactic corona, slowly cycling material in and out of the disk. Some of the gas heated by stars and supernovae is lifted upward, escaping the disk for a while before falling slowly back down. These slow, soft fountains can take millions of years to complete a single cycle. They are part of how the galaxy breathes. And every heavy element in your body, every atom of iron in your blood, every atom of calcium in your bones, every atom of carbon and oxygen and nitrogen in everything you have ever known, all of it was made inside an earlier generation of stars and then released into the galaxy as those stars died. The Milky Way is, quietly, a great, slow forge. It takes simple hydrogen and turns it into more complicated matter, and then it scatters that matter back into the gas, where it becomes the next generation of stars and worlds. You are, in a soft and accurate sense, made of the older galaxy. So is everyone you have ever met. It is worth letting that truth settle gently. Every breath you take draws in atoms that have, at some point in the long history of the galaxy, been inside a star. Every drink of water contains hydrogen older than the galaxy itself, joined to oxygen, forged in the cores of long-vanished stars. Your own body, in its quiet chemistry, is part of the slow alchemy of the Milky Way. The galaxy did not just allow you. It made you, in a real and elemental sense, out of the slow leftovers of its earlier generations. The interstellar medium, despite its softness, is also where most of the long chemistry of the galaxy slowly takes place. Inside molecular clouds, under the right cold conditions, simple molecules can form, and even more complex ones can begin to assemble. Astronomers have detected, in the cold gas of the galaxy, surprisingly complex molecules, alcohols, simple sugars, the building blocks of amino acids. The galaxy, in its quietest places, is a slow chemistry experiment. Most of those molecules will never become anything. But some of them, here and there, will end up inside young protoplanets and contribute to the slow start of new worlds. The dust grains in the interstellar medium are, in their own quiet way, useful. They serve as the slow surfaces on which simple molecules can stick together and form more complicated ones. They cool the gas by radiating away its heat. They scatter light in soft, painterly ways that we recognize in nebular images as some of the most beautiful sights in the universe. They are the dimmest, most overlooked grains in the galaxy, and yet they are central to almost every story of how stars and planets form. Dark matter, by contrast, has no such role in chemistry. It does not interact with light or with ordinary matter in the ways that allow molecules to form. It simply sits there, in vast, quiet halos, doing the slow work of gravity. It is dark in the most literal sense. It is matter that does not shine. It is matter that does not block light. It is matter whose only signature is the quiet pull it gives to everything else. We do not know yet whether dark matter is made of unknown particles or of something even stranger. We only know that it is there and that it is necessary, and that without it, the galaxy would not be the shape it is. There is something tender about this combination. The Milky Way is held together by a vast, unseen presence we cannot directly experience. It is decorated, on a smaller scale, by tiny grains of dust we can barely see. It is filled with cold, simple gas that quietly turns into more complex molecules sometimes. And then, threaded through all of it, are the stars and the planets and the small lives that any one of them might support. The galaxy is not just a place where bright things hang in space. It is a long, slow weaving of seen and unseen, simple and complex, ancient and newly born. Cosmic rays, the tiny high-energy particles that drift across the galaxy, are not a danger to think about tonight. They are part of the slow background of the disk. They have been moving along the magnetic field lines of the galaxy for billions of years. They are part of the gentle radiation that even the Earth's atmosphere quietly filters out for us every day without our noticing. The galaxy is full of small, ancient particles still in motion, still drifting from their long-ago origins toward their long-ago futures. None of them is hurrying. None of them is troubling. The unseen scaffolding of the galaxy will keep doing its slow work. The dark matter halo will keep holding the disk together. The interstellar gas will keep drifting through its slow patterns. The dust will keep softening the light from distant stars. None of it asks anything from you. It is simply the galaxy being itself around you. The Milky Way is not alone. It has more than 50 known companion galaxies, mostly faint dwarf galaxies orbiting in its wider halo. These companions are much smaller than the Milky Way itself. Some of them contain only a few 100 million stars. Some of them are little more than loose drifts of older stars, scarcely organized, slowly bound to our larger gravity. It is a soft thought to hold. Around our home galaxy drift dozens of smaller worlds of stars, each of them a galaxy in its own quiet right, each of them with its own ancient stars, its own gas, its own slow histories. They are mostly faint. Many of them are too dim to see without dedicated equipment. But they are there, in the dark, around the Milky Way, doing what small galaxies do, gently held by our gravity. The brightest of the companions are the Magellanic Clouds. From the southern hemisphere of Earth, on a clear night, they appear as two soft, diffuse patches of light, separated from the band of the Milky Way by a stretch of dark sky. The large Magellanic Cloud is the larger and brighter of the two. The small Magellanic Cloud floats nearby, smaller and dimmer, but visible just the same. The Magellanic Clouds are small galaxies in their own right, orbiting the Milky Way at a distance of about 160,000 to 200,000 light-years. They contain their own star clusters, their own nebulae, their own slow histories. They have been orbiting our galaxy for billions of years, and over that time, the Milky Way's gravity has gently tugged streams of gas and stars away from them. There is now a long, faint ribbon of gas trailing behind them, called the Magellanic Stream, drifting around the galaxy in a wide, soft arc. To picture them properly, you can imagine two soft, dim companions following the Milky Way through space, joined to it by long, almost invisible threads of gas. They are not equal in size to our galaxy. They are not threatening. They are simply small relatives, orbiting in the wider halo, doing what they have always done. From inside one of them, the Milky Way would dominate the night sky as a great spiral of light, and the people of that imaginary world might give it as many soft names as we have given the Magellanic Clouds. On the other side of the disk, a smaller companion called the Sagittarius dwarf galaxy has been slowly disassembling for a very long time. Its stars have been pulled into long streams across the halo, drifting on tilted orbits that pass through the disk and out the other side. The Milky Way has been quietly absorbing the Sagittarius dwarf, one star at a time, over billions of years. There is no violence in this. It is a long, gentle merging, more like one gas slowly mixing into another than anything sudden. In a sense, the Milky Way is a quiet collector. Its halo is full of the remnants of small galaxies that have, over cosmic time, drifted close, been gently torn apart by gravity, and been folded into the larger structure. These ancient mergers are part of how the galaxy grew. Many of the oldest stars in the halo are not native to the disk. They are the stars of long-vanished smaller galaxies, gathered into our gravity and now drifting on inherited orbits. You can think of it as a kind of family album. The galaxy has gathered, over its long life, many smaller galaxies and made them part of itself. Their stars now turn quietly in our halo, on orbits that remember where they came from but no longer keep them apart. The Milky Way has, in a slow and gentle way, made its companions a part of itself. The galaxy is bigger today than it was billions of years ago, in part because it has been patient enough to fold smaller siblings in. One particular ancient merger has left a clear mark. Long ago, perhaps 8 to 10 billion years ago, a medium-sized galaxy collided with the young Milky Way and was completely absorbed. Its stars now drift through our halo on tilted, ancient orbits. Astronomers sometimes call this lost galaxy Gaia Enceladus, after the spacecraft mission that helped reconstruct the event from the patterns of those orbits today. The Milky Way still carries the memory of that meeting. It has been carrying it, quietly, for most of its life. This long history of mergers also helps explain a particular feature of the disk. Above and below the thin, young disk lies a slightly puffier layer of older stars, called the thick disk. The thick disk holds older stars on slightly more disturbed orbits. It is believed to be the result of those ancient mergers' gentle vibrations through the galaxy long ago that left some of the older stars on slightly tilted, slightly thicker paths. The Milky Way belongs to a small family of galaxies called the local group. The local group includes the Milky Way, our nearest large neighbor, the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller dwarf galaxies. Most of the dwarfs are companions of either the Milky Way or Andromeda. The local group spans roughly 10 million light-years across, and all of its members are gently bound by gravity. They are, in a soft sense, our extended family. The Andromeda Galaxy is the largest member of the local group, slightly larger than the Milky Way. It lies about 2.5 million light-years away. On a very dark night, with patient eyes, you can see Andromeda as a soft, oval smudge of light in the constellation that bears its name. The light you are seeing left Andromeda about 2.5 million years ago, when our distant ancestors were still figuring out how to walk upright on the African savanna. By the time it reaches your eye, it has been traveling for almost the entire history of the human family. There is a tenderness in that. When you see Andromeda overhead on a clear night, you are looking at a galaxy whose light has been on its way to you longer than your species has been recognizable. The light did not know about you when it set out. It traveled through silence for 2.5 million years, and only at the very end of that journey did it arrive at a planet where someone had grown the kind of eyes that could notice it. The light is older than your story, and yet it ends in your eye. Andromeda is moving toward us. It is approaching the Milky Way at about 100 kilometers per second, drifting through the dark space between galaxies on a long, slow path. They are slowly closing the distance. Slowly. Over billions of years, that gentle approach will eventually become a meeting. The Triangulum Galaxy, smaller than Andromeda, sits roughly between us and Andromeda. It is fainter, harder to see, but it is part of the same small family. From outside the local group, our three main spiral galaxies would appear as a small cluster of diffuse spirals, gently swimming together through the wider universe. The local group is, by the standards of the universe, a small, quiet neighborhood. There are clusters of galaxies elsewhere, true clusters, with hundreds or thousands of members packed together, hot with X-ray gas and dramatic mergers. The local group is not one of those. It is a small, peaceful gathering, 2 large spirals, a smaller third spiral, and a few dozen dwarfs. Most of its members orbit the 2 large galaxies in long, gentle loops. The local group is, in many ways, an island of quiet inside a wider cosmic story. The dwarf galaxies that orbit the Milky Way are themselves worth knowing. Each of them is a galaxy in its own right, with its own ancient stars, its own slow histories, its own shape. Some of them are barely more than 1,000 light-years across. Some of them contain only a few 100 million stars, far fewer than the Milky Way, but still a great many by any human measure. They drift through the halo on long orbits, mostly out of sight to ordinary eyes. From inside one of those dwarf galaxies, the night sky would be different. There would be fewer stars overhead. The Milky Way itself would dominate the view, hanging in their sky as a great spiral of light. The Magellanic Clouds in particular are gentle to think about. They are visible only from the southern hemisphere of Earth, and only as faint, diffuse patches of light. They were called clouds by sailors who saw them softly hanging above the southern horizon at night and were not sure what they were. Now we know they are entire galaxies, small ones, but real galaxies orbiting our larger one, slowly being shaped and stretched by our gravity. Long ribbons of their gas trail through the space around the Milky Way. They have probably been our companions for billions of years. The Andromeda Galaxy is the largest member of the local group, slightly larger than the Milky Way. It is the most distant object that the unaided human eye can reliably see, at least under truly dark conditions. The light from Andromeda has been traveling for about 2.5 million years before reaching your eye. When you look at it, you are seeing it as it was when our ancestors were small, fur-covered creatures only beginning to walk upright. The light is older than the human story. That fact, more than almost any other, is one of the simplest gifts of looking up at the night sky. The light overhead is older than you. The light from the brightest stars is decades or centuries old. The light from the band of the Milky Way's center is tens of thousands of years old. The light from Andromeda is millions of years old. You are, every clear night, looking through a small, gentle window into time. The galaxy is full of memories of itself, all of them slowly arriving, in their own time, at someone's eye. It is also worth knowing that the companions of the Milky Way include some galaxies that are too small and dim to see without serious effort. There are ultra-faint dwarf galaxies gathered around our halo that contain only a few 100,000 stars. They are tiny by galactic standards. They are faint enough that astronomers have been finding new ones, slowly, for decades, and there are likely still others waiting to be noticed. The galaxy is gently surrounded by these small, hidden companions, all of them quietly orbiting in the long, slow halo, none of them asking to be seen. The smaller companions of the Milky Way are out there in the dark, quietly drifting on their long orbits. The Magellanic Clouds, the Sagittarius Dwarf, dozens of fainter companions. They are not lost. They are not lonely. They are part of the larger family the galaxy has been gathering for a very long time. They are doing fine, in their slow way, in the soft halo of our home. In about 4 billion years, Andromeda and the Milky Way are expected to meet. Their disks will pass through each other, slowly. Their gravitational pulls will reshape both galaxies. Over many more billions of years after that, they will gradually merge into a single larger galaxy. It is easy to imagine that this kind of meeting must be violent. The word collision sounds like crash, like impact, like something brief and loud. But on a galactic scale, collisions are not like that at all. The space between stars is so enormous that even when galaxies pass through each other, the chance of any two stars actually striking each other is essentially zero. The galaxies are not made of matter the way two solid objects are. They are made mostly of empty space, with stars scattered through it, far from one another. You can hold this gently. The galaxies will meet, but they will not really crash. They will pass through each other the way two clouds of fireflies might pass through each other in a wide field at night. The fireflies might be aware of new neighbors, briefly. None of them would actually run into each other. The cloud as a whole would change shape, mix, and slowly reorganize, but each individual firefly would simply continue along its own path. When the two galaxies meet, individual stars will not collide. The Sun will probably never come anywhere near another star. What will change is the broader shape of both galaxies. Their disks will be pulled into long tidal arms. Streams of gas and dust will spill out of the merging structure. Over billions of years, the orbits of the stars will be slowly stirred. The gentle rotation of two clean spirals will give way to a slower, rounder, calmer turning of a single, larger galaxy. Astronomers sometimes give the future merged galaxy a soft nickname, Milky, a word borrowed from both names at once. It will not be a spiral. It will most likely be a large, gently rotating elliptical galaxy with stars drifting on a wider variety of orbits. It will shine softly in many colors, with old stars gathered at its heart and younger blue-white stars scattered through its outer regions where there is still some gas to make new ones. The Sun will probably survive the merger. It is unlikely to be flung out of the galaxy. It is unlikely to collide with anything. It may simply find itself on a different orbit, in a different part of a much larger galaxy, with a very different night sky overhead. The constellations we know now would, by then, have long ago dissolved into new patterns. But the Sun itself, if it still shines at all, will be quietly drifting along in this new home. The Triangulum galaxy may eventually join the merger as well. If it does, the three main spirals of the local group will become a single larger system. The story of three galaxies will become the story of one. The smaller dwarfs around the local group will continue to drift in for billions of years afterward, each of them slowly being folded in, the way the Sagittarius dwarf is being folded into the Milky Way today. The image is, in a way, soft and reassuring. There will not be a moment of catastrophe. There will only be a long, slow shaping. The local group will continue to gather itself together. The galaxies will keep doing what galaxies do, simply on a longer and slower timetable than anyone alive today can witness. Long after the merger begins, the merged galaxy will go right on turning, and its stars will go right on living and dying, and its gas will go right on cycling through the slow forge of new generations. By the time the merger is complete, Earth itself will likely no longer be a habitable world. The Sun, by then, will have grown into a red giant or beyond, and the Earth's surface will be very different from anything we know now. But the merger will not be the cause. The galactic story and the planetary story have always been on different timetables. Even at 4 billion years from now, the larger galaxy will be calmly going about its work, while the planets and stars within it live their own much shorter lives. Beyond the local group, our small family is drifting toward the Virgo cluster, a much larger gathering of galaxies many tens of millions of light-years away. We are not heading toward Virgo to merge with it. Cosmic expansion is gently pulling the rest of the universe away from the local group. But within our region, the slow gravitational flow toward Virgo and toward larger structures still organizes our motion. Our true cosmic address is not just the solar system, or the Milky Way, or the local group. It is also a vast structure called Laniakea, a region of space where galaxies all gently flow toward a common gravitational valley. The Milky Way is one of perhaps 100,000 galaxies in Laniakea, drifting along its slow internal currents, all participants in the same long flow. Even Laniakea is not the whole picture. Beyond it lie other superclusters, other vast filaments and walls of galaxies, other gentle networks of structure that the universe has organized over billions of years. The Milky Way is part of this much larger pattern, drifting along its tiny corner of one of the universe's great structural threads. We are, in a soft sense, threaded into the cosmos. We are not at the center. We are not at the edge. We are part of a quiet, much larger weaving that no one will ever fully see. Far in the future, after the merger is complete and the gas of the new galaxy is slowly used up, Milky will keep shining, but more quietly. The most massive stars will burn through their fuel and die out first, leaving only smaller, longer-lived stars behind. Over billions of years, the color of the galaxy will gently shift from blue and white to soft yellows and reds. Eventually, when star formation has nearly stopped, the galaxy will be made up mostly of red dwarfs, which can shine for trillions of years. The galaxy will look softer, dimmer, redder, but it will still be there, still turning, still holding everything inside it. The image of the future merger between the Milky Way and Andromeda is, in some ways, a strange and tender one. Two enormous spirals, gently approaching each other across 2.5 million light-years, gradually closing the distance over billions of years. They will not crash. They will not explode. They will simply, slowly, find each other. If you imagine watching it from a great distance, sped up so that millions of years pass in a moment, you might see the two spirals first appear as two slightly tilted disks swimming toward each other through the dark. Long before they meet, their gravity would begin to disturb each other's outer edges. Streams of stars would begin to spill out of both galaxies, drawn into the space between them. Tidal arms would form, long curving tails of stars stretched out by the slow pull. The galaxies would begin to stretch toward each other, reaching across the gap. When they finally passed through each other, the disks would not collide as solid objects. They would interpenetrate, like two clouds of light passing through each other in slow motion. Some of the gas would flow inward toward both galactic centers, perhaps triggering bursts of new star formation. Some of the stars would be flung onto wider, more chaotic orbits. The neat spiral patterns would dissolve. The galaxies would, over many slow passes, settle into a single, larger system. After many billions of years, the two galaxies would no longer be two galaxies. They would be one. The new galaxy would not be a spiral. Spirals are delicate structures that depend on a thin disk and a steady rotation. The merger would shake that delicacy out of both galaxies. The new system would most likely be a softer, rounder, gently rotating, elliptical galaxy, with stars on a wide variety of orbits. It would be larger than either of its parents had been alone. It would still hold most of the same stars. The Sun, if it still shines by then, would be one of those stars, somewhere inside it, on a new orbit that no longer passes through any of the spiral arms we know now. It is calming, in its own way, to know that none of this is any cause for worry. 4 billion years is a long time. The Earth itself will be a very different place by then, regardless of what is happening at the galactic level. Most of the stars and most of the planets will simply continue doing what they do. The merger is a background event in their lives, the way the slow shift of a continent is a background event in the lives of trees. The lives unfold. The merger unfolds. They never really collide. When the merger eventually happens, far in the future, it will be one of countless similar, quiet meetings happening across the universe. Galaxies merge all the time, on cosmic timescales. The universe is full of slow folding togethers, gentle blendings, patient rearrangements. The Milky Way and Andromeda are simply going to take their soft turn at this very ordinary, very slow process. They are not unique. They are not in a hurry. They are simply doing what galaxies do, given enough time. The future merger with Andromeda is not happening tonight. It is not happening this year. It is not happening in any time you will ever live to see. It is, like so many of the galaxy's larger motions, far enough off that you do not need to think about it. It is enough that the future of the galaxy is gentle. It is enough that the merger, when it comes, will be slow and patient, like everything else the galaxy does. The Milky Way is old. It is not the oldest thing in the universe. The universe itself is older, a little under 14 billion years old, as far as we can tell. But the Milky Way has been around for almost all of that time. Its oldest stars are nearly as old as the universe itself. Its disk has been gathering and turning for 10 billion years or more. Compared with anything you have ever known, the galaxy is patient beyond comprehension. It has also been gently aging. Star formation in the Milky Way has been gradually slowing for billions of years. The disk continues to make new suns, but at a quieter pace than in its youth. Long ago, the galaxy was a brighter, busier place, lit up with more young blue stars and more active regions of star formation. Now, it is a more settled, more middle-aged galaxy, quietly producing only a few new stars each year, and content to let most of the existing ones drift through their long lives. You can think of it almost the way you think of a person settling into a calmer phase of life. The earlier years were busier, brighter, more dramatic. The later years are gentler, slower, more reflective. The galaxy is in this gentler phase now. It is not finished. It is simply less in a hurry than it once was. Eventually, the supply of fresh gas for new stars will dwindle. The slow fountains and flows that recycle material in the galaxy will, over billions of years, become less efficient. Gas will continue to fall in and feed the disk for a long time, but at a steadily decreasing rate. The galaxy will keep making stars long after we are gone, but with each passing billion years, the rate of star formation will gently fall. One day, far in the future, almost no new stars will form in the galaxy. The brightest, most massive stars will all have lived and died that they live on the shortest timetables. The medium-sized stars, like the Sun, will have lived their longer lives and become, in turn, white dwarfs, slowly cooling. Only the smallest, longest-lived stars, the red dwarfs, will keep shining. Trillions of years from now, the galaxy may be little more than a soft, red ember in a much darker sky. The white dwarfs of older stars will keep cooling. The red dwarfs will keep slowly burning. The galaxy will not have ended. It will still be turning. It will still be holding its stars. But its color will be very different. The light will be slower, gentler, redder, less ambitious. There is something tender in imagining that distant version of the galaxy. It is not gone. It is just quieter. It is still home to whatever life might still exist around its long-lived red dwarfs. Its sky is dimmer, rather, gentler, but it is still a sky. Stars still shine. Planets still orbit. The galaxy still turns. Time has simply softened it. On scales much larger than the local group, cosmic expansion is gently carrying galaxies away from one another. Over enormous spans of time, the rest of the visible universe will move farther from us, faster, until distant galaxies become harder and harder to see. The local group will not be torn apart by this expansion. Gravity within our small family of galaxies is too strong for that. But the larger universe, beyond our group, will slowly become more remote. In the very far future, after Milky has formed and settled, the night sky of a planet inside that galaxy might be largely empty of distant galaxies. The merged galaxy itself, lit by its own stars, will be almost the entirety of the visible universe, with only a faint scatter of more distant lights still reaching it. By then, any skywatcher would see Milky as their whole sky, with the void beyond it stretching wider and quieter than anything imaginable now. It is worth remembering that none of this is sudden. None of these timelines are dramatic in the way human stories are. They unfold over billions or trillions of years. They move slowly enough that any individual life, any star, any planet, any person is over before the larger picture has moved at all. It can be a relief to know that. The largest changes in the universe are too slow to ever interrupt the small changes in your day. The galaxy is moving, but it is moving on a timetable that does not even register in human history. Whatever happens to Milky, whatever happens to the wider universe, it will happen far beyond any time you will ever have to live through. For now, the Milky Way is in a calm, full middle age. It has had its early bright bursts of star formation, its ancient mergers, its long settling. It has not yet entered the slow fade. It still has gas to make new stars. It still has spiral arms. It still has the long, slow turning that it has had for billions of years. It is here. It is doing what it does. And we are part of it, gently, for a very small fraction of the time it has been turning. The slow aging of the Milky Way is not a tragedy. It is simply what galaxies do. Star formation is a process. It uses up material. It produces remnants, white dwarfs, neutron stars, stellar mass black holes. Some of those remnants drift quietly through the disk. Some of them eventually return their material, in supernovae or other gentle ways, to the gas of the galaxy, where it can be reused. But not all of it returns. Some of it is locked up forever in compact remnants that no longer take part in star formation. Over time, that means the supply of fresh, available gas in the disk slowly shrinks. Star formation cannot continue forever at the same rate. It naturally tapers off, gently, as the available material dwindles. The galaxy is in this sense a long-term self-rationing system. It does not exhaust itself in a sudden burst. It eases into a slower future at a pace too gradual to notice from any one moment. Far in the future, the Milky Way's disk will have used up most of its star-forming gas. New stars will become rare. The galaxy will be made up mostly of older stars on long orbits, with red dwarfs being by far the most numerous kind. The light of the galaxy will gently shift toward redder colors. The galaxy will look softer, dimmer, and warmer at the same time. It will not look dead. It will look settled. Beyond that future, in even longer timescales, the universe itself will continue to expand. The visible universe outside the local group will become harder and harder to see. Galaxies that are now far away will, over enormous periods of time, drift even farther. The Milky Way will not be alone in this Andromeda, and the smaller dwarfs will all still be here, gravitationally bound to each other. But the wider universe will become more and more distant. The future galaxy will look out at a softer, emptier sky. There is, even in this, no real sadness. These changes are not painful. They are too slow to be felt. They are unfolding over timescales that human emotions cannot really attach to. The galaxy is simply doing what galaxies do over the long run. It is not in pain. It is not declining in a way that should make anyone uncomfortable. It is just slowly turning into a calmer, redder, gentler version of itself. The future of the galaxy contains many quiet stages we will never witness. The slow exhaustion of star formation, the long survival of red dwarfs, the drifting of white dwarfs and neutron stars and stellar mass black holes through the disk, the very slow cooling of the universe at large. None of these things will be sudden. None of them will be loud. They are all part of a long, soft unfolding that does not need any of us to attend it. The galaxy is quietly continuing its long story, and the story will go on long after every story we know has been forgotten. The long horizon of the galaxy is far beyond your lifetime, and the lifetime of every human being who will ever live. That is not a sad thing. It is simply a soft truth. You do not have to carry the future of the galaxy on your shoulders. The galaxy is carrying itself the way it always has. You are simply riding along for a small, quiet stretch inside something old enough to hold every horizon at once. There is something soft about the idea that the galaxy has always been here and will continue to be here long after every story we know has ended. Not in a sad way, simply in a way that puts everything into a calmer perspective. The galaxy was already old when the Earth formed. The Earth formed about 4.5 billion years ago from a cloud of dust and gas spinning quietly around a young sun. By the time that cloud collapsed and gathered, the Milky Way had already been turning for several billion years. The disk had already settled. The bar at the center had already organized itself. The spiral arms had already been doing their slow work for a very long time. The galaxy did not begin with us. It only carried us along once we appeared. Every story you know is younger than the galaxy. Every memory you have is younger than the galaxy. Every language ever spoken on Earth, every song ever sung, every name ever given, every loss and every joy, and every long, quiet evening like this one, all of it has happened well within a small fraction of one of the galaxy's many slow turns. And the galaxy has barely noticed. You can hold this thought lightly. It does not have to mean that nothing matters. It can simply mean that the galaxy has been gentle with us. It has been making space for our small story to unfold. It has been carrying the sun around its slow orbit, giving the Earth a stable place to gather oceans and air, allowing all the long, slow weathers of life to happen. The galaxy did not know we would come along, but it has been patient enough to hold us. It is a very kind universe in that respect. The galaxy did not need us. The sun did not need us. The Earth did not need us. Yet here we are, anyway, somehow gathered out of starlight and slow chemistry, given a small share of the long story. The galaxy has not just carried us. It has, in the quiet way of large, patient things, made us at all. We are a small flicker of life inside something old enough to keep its own counsel. Tonight, as you let your shoulders soften, the galaxy is turning slowly outside. The sun is moving along its long orbit, carrying you with it, at about 220 kilometers per second. The dust, grains, and gas in the spiral arm nearby are drifting through their own slow patterns. The central black hole, 26,000 light-years away, is sitting quietly, drawing in occasional small amounts of gas, producing only the faintest occasional flicker. At the very edges of the disk, in the soft outer halo, ancient stars, older than the Earth, are still on their long, looping orbits. The Magellanic Clouds are drifting out beyond the disk, gently held by the larger gravity of our halo. Andromeda is approaching, slowly, 4 billion years from a meeting that will not happen in any time we can really feel. The local group is drifting along, gently bound, gently turning. Laniakea is flowing gently, far beyond our daily concern. The whole vast structure is calm, in the way only very old, very large, very patient things can be calm. You have permission, here, to let it all do its work without you. You do not have to think about it. You do not have to remember it. You do not have to do anything at all. The galaxy does not need your attention. It has been turning fine without it for billions of years. Let your breathing slow. Let your shoulders soften. Let the galaxy keep its long, soft turning beyond the walls of wherever you are tonight. The sun is doing its work. Andromeda is doing its work. The black hole at the heart is doing its work. The dark matter halo is doing its work. None of them needs anything from you. There is no scoreboard up there. There is no quiet judge keeping track of how well you are listening. The galaxy is not measuring you. The sun is not measuring you. The night is not measuring you. They are simply being themselves, very slowly, in their very large way. You are allowed to rest inside it. And if you fall asleep before the end of this video, the galaxy will continue without you. The Milky Way will keep turning at the same gentle speed, in the same long quiet, with the same 100 billion stars and unseen halo and slow patient story it has been carrying for almost the entire age of the universe. It does not need you to listen. It does not need you to know. It simply holds you, the way large, slow things hold small ones. We have walked through 100 small facts about it tonight. Its shape, its turning, its stars, its quiet center, its unseen scaffolding, its companions, its long horizon. None of them is the whole thing. The whole thing is much bigger and much softer than any list can hold. The Milky Way is, in the end, just our home. The place we have always lived. The place that has always carried us, even when we did not know it was there. If you have only listened to part of it, that is fine. The galaxy has not been keeping count. Whatever you have heard enough. The rest is still here, still turning, still soft, available any time you wish to come back to it. There is no debt incurred by drifting off. There is no homework to be done. There is only the long, slow turning and your slow, soft breathing and the kind, quiet gravity of a galaxy old enough to hold you without effort. Tonight, while you settle, the galaxy is doing none of these distant things. The far future is far away. The merger is 4 billion years off. The slow fade is much further still. None of those large changes is affecting your room, or your bed, or your breathing. The galaxy in its current form is around you. Its current spiral arms are still where they have been for a very long time. Its current black hole is sitting quietly. Its current dwarf companions are drifting in their slow orbits. Its current dark matter halo is doing exactly what it has been doing for billions of years. You are inside that current. The sun is moving along its current orbit. The Earth is moving along its current path around the Sunday. The moon is moving along its current orbit around the Earth. All of these motions are old and steady. Nothing about them is unusual tonight. Nothing about them is in danger of changing soon. The sun has been doing this for 4.5 billion years. The Earth has been doing this for nearly as long. The galaxy is far older than either. When you let your shoulders soften, you are not stepping out of any of this. You are settling more deeply into it. You are letting the slow current of the galaxy pass through you the way it has always been passing through you. You are not in opposition to anything large. You are simply, quietly, part of it. There is something kind about belonging to something this old. The galaxy has been here for almost the entire age of the universe. It has carried much older stars than the Sun, and it will carry much older ones still. It has been a home for kinds of life we will never know, in places we will never visit, around stars that have already lived and died. And it has been a home for us too, briefly and gently, in the small slice of time that we happen to inhabit. Whatever you are carrying tonight, whatever worries, whatever hopes, whatever quiet weight has gathered through the day, it is happening inside something old, soft, and patient enough to make space for all of it. The galaxy does not need you to resolve any of it. The galaxy is not asking for any of your day's events. The galaxy is simply turning, with you inside it, the way it has always been turning, with everyone inside it. You can rest now. You do not have to do anything. The Milky Way is not waiting on you. It is here. It has been here. It will continue to be here. And it has, in its slow and steady way, made room for your night to be small and quiet and held. So let your breathing slow. Let your shoulders soften. Let the small thoughts of the day drift out into the larger dark. The galaxy is still turning. The sun is still carrying you. The night is still kind. Let yourself be held tonight by something old enough to hold every story, including yours, without effort. So, finally, there is nothing more for you to do. The galaxy has been here for almost the entire age of the universe. The galaxy will continue, in its slow way, far past anything you will see. And the small slice of it that you happen to live inside has been kind enough to hold you, your home, your life, and your night, with no effort at all. Let your shoulders soften one more time. Let your breathing slow one more time. Let the galaxy continue its slow turning while you settle into the quiet. There is nothing to fix. There is nothing to figure out. There is only the long, slow patience of 100,000 light-years of stars gently arched above you, holding you the way it has been holding everyone for a very long time. Tonight, you are at home in the Milky Way. You always have been. You always will be, for as long as you are here. And when you are not, the galaxy will keep turning, kindly, the way it always has. That is enough. That is more than enough. There is no homework here. There is no quiz. There is no test of how well you have listened. The galaxy is not keeping score. It is not even watching. It is simply, slowly turning. You are simply, slowly settling. You can let everything go now, for a while. The galaxy will continue. The sun will continue. The night will continue. None of them needs you to be doing anything in particular. None of them needs you to be awake. Whatever you are carrying tonight, the galaxy is large enough and patient enough to hold next to it. The big sky outside, the soft band of light that has always been there, the slow turning of 100,000 light-years of stars, all of it is making room for you. All of it has always been making room for you, even when you did not know it was there. You can rest. You can drift. You can let your shoulders soften. The galaxy is here. The galaxy will be here. And in this small moment of the long, soft, patient turning, you are part of the galaxy too, gently, simply, without needing to do anything else at all. And so we leave the Milky Way as we found it turning slowly in the long dark, carrying every star and every world without effort. Let your shoulders soften. Let your breathing slow. Let the galaxy keep its quiet without you. Sleep well and good night.